Molecular and structural formula. This is an example for molecular formula. Molecular formula shows the number of atoms present in the molecule. For this one, 3 carbon atoms present in this molecule and 6 hydrogen atoms and 1 oxygen atom. Structural formula shows the number of atoms in the molecule and how they are bonded together. In this structural formula, you can see that there are 2 carbon atoms and how they are bonded together. It means this carbon atom bonded to another carbon atom and this 1 carbon atom on the left bonded to 1, 2, 3 hydrogen atoms, and the carbon atoms on the right are bonded to 1, 2, 3 hydrogen atoms. That is structural formula. But in molecular formula, these 3 carbon atoms, this molecular formula doesn't show how these 3 carbon atoms connected together, and it doesn't show how hydrogen atom and oxygen atom connected with the carbon. That is the difference between molecular formula and structural formula. There are 3 types of structural formula: expanded structure, condensed structure, and skeletal structure. Expanded structure, structure that shows all covalent bonds between atoms, but it does not represent the actual shape of molecule. For example, the C2H6, this structure, it shows this 1 carbon covalent bond to another carbon, and the carbon on the left has 3 covalent bonds with 3 hydrogen, and the carbon on the right has 3 covalent bonds with 3 hydrogen atoms. But this bond does not represent the actual shape of the molecule. In condensed structure, the CH bond and CC single bonds are not shown. For example, in this condensed structure, this carbon is connected to 3 hydrogen, but the single bond of carbon is not shown in condensed structure. The CH3 is actually bonded like this, carbon on the left, CH3. But in condensed structure, the C and H bond is not shown. And then this C has 1 single bond with H. The C also has 1 single bond with the left C on the left. And in the bracket, branches may be written in parentheses. We call this parentheses, or the bond itself. Some condensed structure shows that if it is a branch, this carbon will have 1 single bond with this carbon, but on the branch side, not in the parent chain. So this is the branch in the parentheses. And then the C bond with O, bond with another O, and the O is bonded with a hydrogen atom. So the C single bond H and C single bond C are not shown in condensed structure. Next, in skeletal structure, only the bond C single bond C is shown. So C chains are drawn zigzag. So this is zigzag form of drawing. C atoms are not shown. Only the bond is shown, but not the carbon atom. And then hydrogen bonded to carbon are not shown. So we start with this first one. This has 1 carbon. On here, 1 carbon. And this 1 carbon is bonded to another 3 hydrogen. So 1 carbon need to have 4 bonds in order for the carbon to achieve octet. So 1 carbon need to bond with 4 other atoms, 3 hydrogen here, and then 1 more bond with another carbon. So this carbon has a total of 4 bonds. And then here one more carbon, here one more carbon bonded to 3 hydrogen, and this carbon is double bond with this carbon, and here this carbon has double bond with this carbon and single bond with this carbon, and the total that we can see is 3 bond, double bond, and 1 single bond, and the 4th bond is the bond with 1 hydrogen atom. And then this carbon here has single bond with C, 1 bond, and single bond with Cl, 2 bond, and another 2 bonds are bonded with hydrogen, 2 hydrogen atoms. And then here it's not C, it's Cl atom. We show the atoms other than carbon, you have to write other than carbon and hydrogen, you have to write down that atom. Okay, functional groups are shown. This is functional group halogen. This is halogen, so you have to write down the functional group in skeletal structure. Okay, remember, in expanded structure, all covalent bond, all atoms are shown. In condensed structure, all atoms are shown, but the bond between C and hydrogen and the bond between C and C are not shown in condensed structure. But in skeletal structure, only carbon-carbon bond is shown. It doesn't matter whether it's single bond, double bond, or triple bond, you have to show the bond. The carbon atom and the hydrogen atoms are not shown in skeletal structure. These are the expanded, condensed, and skeletal examples. So this is for CH3, CH2OH, CH3, CH2OH. Okay, this is how you draw expanded structure. This carbon is bonded to 3 hydrogen, and the second carbon is bonded to 2 hydrogen, and the two bonds, other than that, the 2 bonds, it's single bond with carbon and it has single bond with OH. So this is how you write down OH, not HO. C, single bond, O first and then H. The carbon is bonded to oxygen, not hydrogen. The hydrogen is bonded to oxygen. Okay, so COH, not HO. So in condensed structure, it doesn't show the C single bond C or C single bond H. So in condensed structure, just CH3. Okay, we start from the left, CH3, and then CH2, okay, CH2, and then OH. So this is condensed structure. And then skeletal structure start from the left. We have CH3 here. So the first carbon here, C, and then H3. The single bond C, single bond H is not shown in skeletal structure. Hydrogen is not shown in skeletal structure. Okay, the CH3, and then here CH2 and OH. This is functional group, so you have to write down the functional group in skeletal structure. Next, CH3, CH2, CHO. Okay, so this is CHO. This is CHO, the carbonyl group. Okay, in condensed structure, CH3, no single bond is shown. So start from the left, CH3, and then CH2, CHO. So CHO means this carbon double bond with O, and that carbon has single bond with H. If COH, it means C single bond with O, and then that O single bond with H. So that's the difference between CHO and COH. Okay, if COH, C single bond O. If CHO, C double bond O single bond with H. That is CHO. Okay, so here start CH3 here, then CH2, CHO. The C double bond O, the C single bond with H. Okay, the functional group is shown. And then next, CH2, CH, CH3. Okay, this we start on the left, CH2, right? This C bonded to 2H, CH2, and then the next C is CH only, CH. In condensed structure, you have to show the double bond, the triple bond. Okay, the double bond. So CH2, double bond, CH, and then CH3. And this is skeletal structure. The first carbon here, this is one carbon, C, and that bonded to 2 hydrogen atoms, and then that C double bond with the next C, the second C. Here is CH, okay, CH, and then this one is CH3. This is C bonded to other 3 hydrogen atoms. Next, this is the cyclic structure, expanded cyclic structure. All carbons bonded together in a cycle, so this is what we call cyclic. This is condensed structure. In condensed structure, if it is a cyclic structure, you have to show the C single bond C. Normally in condensed structure, we don't show C single bond C, but if it is a cyclic structure, you have to show C single bond C to show that it is a cyclic structure. And this is skeletal structure. No hydrogen atoms or carbon atoms are shown. Here, expanded cyclic for C double bond C. So this is example for benzene ring. C double bond C alternate with C single bond C. So the double bond alternate with the single bond. So this is expanded structure. This is how you draw the condensed structure. You still show the C single bond C and C double bond C in condensed structure to show that it is a cyclic structure. And this is how you draw the skeletal structure for benzene ring. Next, classification of carbon atoms. We have 4 classification of carbon atoms: primary, secondary, tertiary, and quaternary. So for example, here we have methane. The carbon is bonded to 4 hydrogen atoms. So no carbon is bonded to this carbon. The carbon only bonded to hydrogen. No carbon atom bonded on this carbon. So 0 carbon attached on this carbon. So here no class. And then next, we focus on this. You have propane, 3 carbon atom in total, and we focus on the carbon in red. So we focus on this carbon. We focus on this carbon. We want to classify this carbon. You have to classify. So if we were to classify this carbon, you have to count the number of carbon that is attached to this carbon. So on this carbon, 3 hydrogen atoms are attached to this carbon and 1 carbon is attached to this carbon. So if 1 carbon attached to this carbon, we focus on this carbon, 1 carbon attached to this carbon. So this carbon, we call it primary carbon. Okay, primary carbon, because only 1 carbon attached to this carbon. And then focus on the next carbon here. If we have to classify this carbon, we count the number of carbon that is attached to this carbon. 1, 2. So these 2 carbons are attached to the carbon in the middle. So the class for the carbon in the middle is secondary carbon. Next, focus on this carbon again. Focus on this carbon again, and count the number of carbon attached to the carbon in the middle. 1, 2, 3. 3 carbons attached on this carbon. So this carbon class is tertiary carbon. Next, on this carbon, 4 other carbons are attached on this carbon. So the class for this carbon is quaternary carbon. If you came across the carbon that has multiple bond, no class for multiple bond carbons. Okay, in multiple bond, we don't count the number of carbon attached on that carbon. Just straight away, no class for multiple bonds carbon. We only count the single bond carbon attached, not multiple bond. For multiple bond, no class. Next, classification of hydrogen atoms. Same like carbon, we have primary, secondary, and tertiary only. We don't have quaternary hydrogen. Okay, look at this one. This is the carbon. If we focus on this carbon, count the number of carbon attached to this carbon. So 3 hydrogen attached to this carbon, and the carbon here is attached to this carbon. So only 1 carbon attached to this carbon. So you call this carbon primary carbon. And if you want to classify the hydrogen, you look at the hydrogen that is attached to what class of carbon. This 3 hydrogen is attached to primary carbon. So we call these 3 hydrogens primary hydrogen because the hydrogen is attached to primary carbon. Next, if you look at this carbon, 2 other carbons attached to this carbon. So there's 1 carbon attached to this carbon, 1, and then another 1 carbon attached to this carbon. So 2 carbon attached on this carbon. If 2 carbon attached on this carbon, you call this carbon class secondary carbon. And if you have to classify the hydrogen, look at these 2 hydrogen. There's 2 hydrogen attached to the secondary carbon. So you call that hydrogen secondary hydrogen. Same goes to the next one. This is tertiary carbon because 3 other carbons attached to this carbon. And the hydrogen that is attached to the tertiary carbon is tertiary hydrogen.